Yeah, so I will share my screen, and if you have any doubts, you can ask. Anybody with any questions in the yesterday's session? So in yesterday's session, we have discussed how to fit the model, and we have discussed the trend test split, and after that, we have discussed how to do the trend test split. So I'm waiting for your questions if you have any, and if you don't have, we'll start the session. All right, so let's start this. We'll see what is trend test split. So in this thing, we have discussed that we divide your data into two equal parts, not equal parts, two parts. One is used for training of your data, training of your model, and another is used for testing your model. So we have training, we have testing. So training set is used for training the model, and testing is used for testing the model. If training is high, then you will achieve the high accuracy. If training is low, it's not good, then you can there would be less accuracy. So in this thing, we generally divide your data into 70-30 ratio or 80-20 ratio, 75-25, depending upon the user. But we do not generally go below to 70-30, 60-40, we don't go. The reason is very, the reason is very easy. We want to give as high training as possible to our model to get the high accuracy. So uh, now we have this question, what do you mean by random step? So what is random state over here, and what happens if we don't give that? Why it is used? So the random state is, suppose you have a data in which you have one, two, three, and four. Suppose this is your data. Now what happens is, let's say we are interested to do the trend test split for this data. So let's say 80-20 is our ratio. So 80% of, let's say one more, let's take one more thing over here, one more training data, one more data set. Let us take this thing. So if we are doing 80-20 means 0.8, 80% would be there in your training. So 0.8 of 5, because we have 5 data set. So it would be, it would be 4. 4 would be there in your training, and remaining 1 is there in your testing. Now let's say if you are using random state, then what it will do is it will fix the combination. It will fix the combination. Means suppose if the random state is 1, if the random set is 1, then for an example, your splitting would be like this. Just for an example, you will have a splitting like this: 1, 2, 3, and 4. This is a part of training and testing. In testing, you have this random set 2 will have another combination. Let's say for random set 2, you have another combination which is, so another combination means this is your training data and this is your testing data. This is your training, this is your testing. So depending upon the random state that you are selecting, it will try to change the combination for training and testing. Now for random state, if you don't set the random state, if you don't set the random state, then what will happen is it will not lock or fix the combination. It will not lock or fix the combination. That's what it will do is, if you restart and run all the cells, it will uh, change the combination, and it will give different accuracy every single time. Let's do this. What I'm trying to say is, As you know, here, let's say if we are using the random state, yeah. Suppose in linear regression, my accuracy is 82%. If I'm using the random state is equal to 3. If I'm using random state is equal to 3, the accuracy that I'm getting is 82.73%. Right? Now let's see what happens if I don't use random state and I'm doing restart and run all the cell. The R2 score earlier I had is 82.7. Now see it will change for each and every iteration. It will not fix the combination over here. See for random state we are not selecting the random state and the accuracy is 80%. Now if I restart and run all these things, it will again give me the another R2 score. See what is happening now. What is my accuracy? It is 84. Right? Now if I give another random set, let's say is equal to 5, and if I'm again running this thing, my accuracy will change 79. So depending upon the random set, the combination will change and you'll get the different accuracy. Now if you see, we are getting 83, right? So random set will just log the combination depending upon the data set, and it will just fix that particular combination. And if you restart and run all, still your accuracy will not change. Now it is 83. If I restart and run all this thing, my accuracy will not increase or decrease. So if I am doing restart and run all, my accuracy is still not changing, right? That's the use of random state. And there is no any rule to select the random state. There is no any rule to select the random state. This is totally depending upon trial and error method. There is no any rule to select the random state. Now let us start to do the same thing. Now we are interested to go with the model building part for our logistic regression, right? So what I'll do is I'll quickly do the next thing. So as part of your model building, these are the steps. I'll quickly take this out and I'm going to paste it over here. So now your first step is object creation. In that, what we'll do is we'll import the package. So in this thing, uh, we are interested to work on logistic regression. So we'll import that package. So if I don't know the package name, I'll quickly search it on official documentation of sklearn, and I'm going to call this package over here. This is my package name. I'm importing this thing. Now, uh, so what is my first step? I'll quickly give heading as step 1, object creation. So model is equal to logistic regression. This is my package. Step 2 is your model fitting. So I'm going to fit my model. As we already have seen this thing, we always fit it on x train and y train. So x underscore train and y underscore train. I'm going to fit my model. This is my model. So your step number 3 is model prediction. So you can directly copy this thing or you can write down. So y underscore pred is equal to model dot predict x underscore test. So this is a model prediction. Now your last step is model evaluation. In this thing, what you're going to do is you are going to check the accuracy. So what I'll do is I'll call the package name for accuracy score, which is this from sklearn dot metrics import accuracy score. And what I'm going to do is I want to check my accuracy, so I'll copy this, and we always take help of y test and y pred. We'll compare this two set y test and y pred to check the accuracy. So my accuracy is 74.45%. So in this way, we have successfully uh, fitted the model for logistic regression. Now, what are the different evaluation metrics that we have for classification? Let's have a look on this. So we have accuracy score, F1 score, precision score, recall score, ROC, AUC score. These are the different evaluation for classification. For regression, which is a linear regression, we have this explained variance score, maximum error, mean squared error, root mean squared error, R2 score. So these are the different evaluation metrics that we have for regression. You can quickly have a look on this thing. And right now, if you have any questions in these steps that we have discussed for logistic regression plus random score, if you have any doubts, you can ask. And if you don't have any doubt, we'll start with the next part, which is your evaluation metrics that we use for to check the performance of the ML model. So for regression, we have different evaluation metrics. Regression means whenever you have target variable as continuous और इन numbers. अगर तुम्हारा टारगेट वेरिएबल नंबर्स रहेगा या फिर कंटिन्यूस रहेगा, then it is regression. What is classification? If your target variable is categorical or in the form of string, अगर तुम्हारा target variable categorical रहेगा, then that is your classification problem. So let's have a break for 2 to 3 minutes. I'm waiting for your questions if you have any. If you don't have, we'll start with this particular topic.
Sir, can you explain one more time, about random at random this
Random
and
state.
yeah,
See, what is a random state? If you we were not giving random state, we were getting the different accuracy every time. Why we are getting
sir.
different accuracy? Because if you are not locking this combination, एंड अगर आप रिस्टार्ट एंड रन ऑल कर रहे हो तो ट्रेनिंग में हमेशा अलग सेट जाएगा, टेस्टिंग में हमेशा अलग सेट जाएगा, इसके कारण आपका एक्यूरेसी चेंज होगा.
Okay,
एंड अगर आप स्टेट रैंडम स्टेट, इफ यू आर लॉकिंग दिस थिंग, सो फॉर रैंडम स्टेट वन यू विल ओनली एंड ओनली गेट दिस कॉम्बिनेशन. तो आप कितने भी बार रिस्टार्ट एंड रन ऑल करोगे सेल, तो आपका एक्यूरेसी चेंज नहीं होगा. वाई? बिकॉज यू आर लॉकिंग दिस कॉम्बिनेशन, ट्रेनिंग एंड टेस्टिंग. तो ट्रेनिंग में हमेशा यही डेटा पॉइंट्स रहेगी, उसके कारण आपका एक्यूरेसी चेंज नहीं होगा. So that is why we use the random set to log the combination, right?
okay, sir.
All right, let's have a break for 2 to 3 minutes, and then we'll start with the evaluation metrics for regression as well as classification. So let us start to discuss the classification evaluation matrix first. So why we use evaluation matrix? Because we need to check the performance या फिर accuracy of your model. We need to check the performance of my machine learning model. I want to check the uh, efficiency of my model. So, for an example, if I fit this model on future data, the data that we'll get in future, how will your ML model will work on that? How efficiently your model will work on this type of data? We have to check this. So what we'll do is, let's start this. We are studying the evaluation metrics for classification. Evaluation metrics for classification. So here we have different evaluation metrics. That is nothing but, first is accuracy, second is confusion matrix, then we have precision, recall, F1 score, AUC, ROC curve. We have this thing for your as part of your classification matrix, evaluation matrix for your classification, right? So let us discuss the first, which is known as accuracy. But in order to understand this, we will take an example over here. So what is the example we have with us is, as you know, classification is nothing but predicting class labels. So if your output is binary, then we use the classification. For an example, let's say your output is positive or negative. So we have two classes, या फिर class 1 and class 0, or else we have true or false, or we can have whether the mail is spam or not spam. These are your examples. So this is our example. Let's take this example. We are interested to build the machine learning model which will predict whether the given mail is spam or not spam. This is a problem statement. So what I'm doing is, for spam, I am considering this as positive. For not spam, let us consider this as negative. So this is positive class, this is negative class, right? Now, in order to understand this concept, we need to understand confusion matrix first. So what is confusion matrix? Suppose these are your actual values. These are your predicted value by your machine learning model. ये आपका predicted values है machine learning models का, ये है actual values. In this thing you can have positive, you can have negative. मतलब actual case में, actual data में it is positive or negative. In this case, in whether my machine learning model has predicted it as positive or negative, right? So if your machine learning model has predicted it as positive and in actual case it is positive, so this is known as true positive. अगर तुम्हारे actual case में data में it is positive and your model has predicted positive, so this is your true positive. In your actual case, if it is negative but your model has predicted it as positive, so that is your false positive. Means your model has predicted it false positive. We have false negative with us. What do you mean by this false negative? In actual case it is positive but your model has predicted it as negative, so it is false negative, falsely negatively predicted. And then we have actual negative predicted negative, so it is true negative. So we have true positive, false negative and true negative. And this is known as your confusion matrix. So what I'll do is I'll quickly take this out. I'll take the image of this confusion matrix and I'm going to paste it over here. So this would be my confusion matrix as we have discussed it over here. Now, as you know, if my actual value is positive and my model has predicted it as positive, so both the predictions are correct. So this is your true correctly predicted value, and this is also in actual case it is negative, and in predicted your model has predicted negative, so this is also true negative, and this is correctly predicted. So true negative and true positive, ये जो दोनों है, that is correctly predicted. But on the other hand, this false positive and false negative, it is incorrect prediction. Why it is incorrect? Negative, in actual case it was negative, in predicted or in your machine learning model has predicted it as positive, so this is wrong or false prediction. This is also false prediction. So we have two values correctly predicted, two values incorrectly predicted, and based on this thing the formulas and the further things will be aligned. Now, as you know, this is error because your model has done the error over here while prediction. So this is known as type 1 error. This is known as type 1 error, and this is your type 2 error. False negative is your type 2 error. The predicted value is negative but your model has predicted it as positive. This is your type 2, this is your type 1 error. Now we have type 1, we have type 2 error with us. These are the two errors. Now let us actually have a look at what do you mean by accuracy. So we are actually starting this formulas. Now what is accuracy over here? Accuracy is, it simply defines, it measures how often the classifier correctly predicts. How often your classifier correctly predicts. We can define accuracy as the ratio of number of, so it's a ratio of um, the number of correct predictions and the total number of predictions. So out of the predictions, how many we have correctly predicted? The correct predictions are true positive and true negative, as we have already discussed. So in your formula, true positive plus true negative would be there, and the denominator would be everything: true positive, true negative, false positive, false negative. And if you take the ratio of these two, this would become your formula for your accuracy. So this is your accuracy formula, right? Then we have second concept, which is known as confusion matrix, which we already have discussed. This is your confusion matrix. We'll not discuss that. Then further we have another type, which is known as precision. Now, what is precision? It explains how many of the correctly predicted cases actually turn out to be positive. How many of the correctly predicted cases actually turn out to be positive? So, where this is useful, we'll talk about the application now. Where do we use the precision? Precision is useful where the false positive is a higher concern than false negative. False positive is higher concern than false negative. Where this is the where we are interested to apply this precision concept. For an example, you have music or video recommendation system. What do you have is you have video or music recommendation system, or on you can have e-commerce website. So what do you mean by where false positive is a higher concern than false negative? In music or video recommendation, what happens if your recommendation system is giving wrong recommendation for which you are not interested at all? You will lose the customer, right? So you'll lose the customer if there is wrong prediction or wrong recommendation for your e-commerce website, let's say Amazon, or your music recommendation system. So in this case, your precision plays key role, and you have to use that formula. So this is your application where we use the precision formula. So what is precision? Precision, it is defined as the label, or it is defined as the number of true positives divided by the number of predicted positives. This is your precision formula. What I'm doing is I want to find the formula over here. I'm interested to find the formula. So it is defined as the number of true positive divided by number of predicted positive. So what I'll do is I'll write down formula over here. It is true positive divided by number of predicted positives. Predicted positives. So what are the different predicted positive that we have? We have true positive and false positive, which our model has predicted as positive. So this is your formula for precision. And we already have discussed where do we use this precision: in the music or recommendation system and e-commerce website. Then we'll go with the fourth type, which is known as recall or sensitivity. So it basically explains how many of the actual positive cases, explains how many of the actual positive cases we were able to predict correctly with our model. Recall is useful metric where it is useful. So I'll write down this. Recall is useful where false negative is of higher concern than false positive. So for an example, where we can use that, where false negative is of higher concern than false positive. For an example, it is very important in medical industry, medical cases, where it doesn't matter whether we raise a false alarm or not. But the actual positive in this case means the person who are really serious positive cases should not go undetected. तो मेडिकल केस में ये बहुत इंपॉर्टेंट है बिकॉज अगर फॉल्स अलार्म भी बजा, व्हाट डू मीन बाय फॉल्स अलार्म, अगर पेशेंट is not serious and your alarm is, there is a false alarm, if person is not at all serious, then that will work, right? It will not make any uh, hazard to your system. But if it is uh, false negative, means if whether patient is serious, when patient is serious but your alarm is not working, then that will not be the good decision over here. So that in that cases we are actually interested to go with the recall concept. This is your application of recall. So this is your recall, and its formula is, as we have defined this, it is defined as the number of true positives divided by the total number of actual positives. This is your recall. Its formula is recall is equal to true positive true positive divided by true positive plus false negative. This is your formula. So you can quickly have a look at this. This is very important topic, classification metrics, evaluation metrics for classification. That is very favorite questions. This you'll get, you will they will ask you in this in the interview. This is very important question for the interview. So quickly revise this thing, and if you're done with the revision, we can discuss the next part. And meanwhile, if you have any questions, if you have any doubts, you can ask. So this is your evaluation metrics for regression classification. In tomorrow's session, we are going to discuss the evaluation metrics for regression. So this will be a theoretical topic again. Yeah, I want a quick response whether you have any questions or not in this, or it is understood or not. Yes, Vishal, Salman, Chandrabhushan, Rutuja, and Mahesh.
No questions from my end, Vipul.
Yes, what about Chandrabhushan and Rutuja?
Fine, sir. Everything is clear till now.
All right. So this is what we have. Now your next thing is in this next formula is, let's discuss that and we'll stop here for the day because we already have discussed uh, everything is theoretical, so you guys would find it boring if I continue this thing. So let's discuss F1 score. What is F1 score? It is very easy. It's combined idea. What they have done is they have thought on this thing whether what happens if we combine the idea of precision and recall metrics. So they combine this thing, precision and recall, and they have come with the F1 score. So it's a statistical definition. F1 score is the, they have done the harmonic mean, calculated the harmonic mean of precision and recall. What is harmonic mean? Suppose you have two variable A and B. It, its harmonic mean is nothing but it is 2 times A into B divided by A plus B. This is a harmonic mean. Right? This is your formula for harmonic mean. Now, if we are taking harmonic mean of precision and recall, so it would be F1 is equal to, it's a 2 times precision into recall divided by precision plus recall. Right? This will be your F1 score. So let's quickly write down this formula. This is your F1 score formula. 2 times precision into recall divided by precision plus recall. So what it does is, it's very useful F1 score. It punishes the extreme values more, and is an effective, when it is effective, it is effective evaluation metric in the following cases. It is very useful in the following cases. So when false positive and false negative are equally costly, whenever you want to add more, adding more data doesn't effectively change the outcome. And whenever true negative is very high, at that time the F1 score is very, very effective or useful. Right. So this is your F1 score, which we calculate to, which is used as the evaluation metric. Then after we have a sixth formula, which is known as AUC and ROC. We'll study that in tomorrow's session. So AUC is your area under curve, and ROC is your receiver operator characteristics. So we are going to study AUC and ROC in your next session. So let's quickly take the image first, AUC and ROC, and we'll stop here for the day. Yes, so I'll quickly give this thing, this workbook and notebook on your drive. Yeah. So I've given this thing on your drive. Now heading towards your questions or your concern if you have any. All right, I'll take silence as no. Let's stop here for the day. Tomorrow we'll continue with the next part. So thank you. Good night. Bye.